The next question says a car is initially 1.5 meters to the left when the time reads 14.7 seconds. At a later time of 20.5 seconds, the car is at a position of 45.2 meters to the right. Find the car's velocity. So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's see how to solve this one. So let's just write down the givens. You have 1.5 m, so m is a distance, so or position, we'll call it x, and you have 14.7 s, seconds is time, so this is t, and you have 20.5 s seconds, which is another time, and you have 45.2 m meters, that's another distance x, and we want to find the velocity. So we have to interpret these numbers here. So the car is initially at 1.5, so initially here, so 1.5 is x initial, and it's there at the time of 14.7 seconds, and the car moves to the final position here, and so that's going to be at the later time, so 20.5 is t final, and the 45.2 is the final position, and we want to find out what is the car's velocity. So this is a plug. Well, actually there's more. Go back and read it also. It says 1.5 to the left, so that means that this is negative, and or x initial is negative, and 45.2 meters to the right, so this one is positive. So now we're ready to plug in. The equation is going to be, velocity is going to be final position minus initial position over final time minus initial time. And so plugging it in, initial position is a negative 1.5. Initial time is 14.7. I'll do it a little bit differently. I'll just write the formula and just redo it. So we're going to just rewrite. So it's final position. Velocity is going to be final position, which is going to be, in this case here, positive 45.2, and then minus the initial position, which is negative 1.5, and then divided by the final time, which is 20.5, and then minus the initial time, which is 14.7. And calculating that should give you 8.05 meters per second. Okay, and let's do the next one. So here it says a boat is moving to the left at 20 meters per second. If the boat is initially 12 meters to the right, find the boat's position after 55 seconds. So go ahead and pause, do part A, and when you're ready, unpause. You can also try to do part B, but this is just in terms of variables. But I'm just only going to show you the answer for part A. So go ahead and pause and try to do this one. Alright, so let's see what the answer is for this one, but first let's just write down the givens. First number is 20 meters per second. Meters per second is a velocity. And you have 12 meters. Meters is a distance, I'm going to call that one x. And we have 55 s seconds, that's time. And we're trying to find the position, so we're trying to find x. Well, it's still not clear what's happening here, so let's try to draw what's happening. So you have a boat, so this is the ground here. The boat is moving to the left, so left is negative, so we're going to make this negative 20. And the car is initially 12 to the, so let's say this is 0 here. Take that to be 0 at that point. Let's Well, actually, let's make this the origin. So the boat is here, and it's moving to the left, and that position is a positive 12. That's to the right. So to the right means positive 12. So the boat is at positive 12, moving to the left, and 55 seconds go by, and we're trying to figure out where is the boat going to wind up. So what is x final? So we're trying to solve for x final. And the 12 is actually the initial position. So here, the equation we're going to use is velocity is going to be final position minus initial position divided by the time that it takes to go between those 2 points. So we can plug in the velocity is minus 20. We're trying to find x final. X initial is a positive 12. Positive 12. And divided by the time, which is 55. And if you do the algebra, x final is going to equal 12 minus 20 times 55. And that will give you a final position of minus 1,088 meters. The next problem says the bee is initially flying to the right at 0.31 meters per second when the time reads 56 seconds. The bee then changes direction and is flying to the left at 0.24 meters per second when the time reads 78 seconds. Find the bee's acceleration. So pause, try to solve this word problem, and when you're ready, unpause. Let's write down the givens. First number is 0.31 ms, meters per second, so that's velocity. And 56s, that's the time, seconds is time. And next number is a 0.24 ms, meters per second is another velocity. And 78 seconds is another time. And we're trying to find acceleration. So now trying to read the question in more detail. It says, so let's say this is the origin. The bee is initially flying to the right, so initially the bee is going in this direction, so at 0.31. So that is the initial velocity, 0.31, it's positive. And at the time of 56 seconds, so the first t is, or 56 seconds is the initial time. And next, it says, later when you see it, it's flying to the left at 0.24. So when you see it, it's flying around, and when you see it again, it's moving in that direction. So it's to the left, so the final velocity is going to be negative. So the 0.24 is negative, and the 0.24 is the final velocity, and that is also negative. And that's going to correspond to the time of 78 seconds. And we're trying to find the bee's average acceleration between those 2 points. So the equation we're going to use is acceleration is going to be final velocity minus initial velocity over final time minus initial time. And this is a plugin, so acceleration is going to be minus 0.24. Well, actually, show you those numbers. The acceleration is going to be final velocity, which is a negative 0.24, minus initial velocity, which is going to be a positive 0.31, over final time, which is 78, minus initial time, which is 56, and the acceleration should be negative 0.025 meters per second squared.